So a big thing to me is defining what is this proposal, what are the components, so that when you explain the project to the kids, they know not only are we designing a wing, but we're doing this other thing.
The basic idea is that we're going to have the students build a wing, and then we'll load them up. So we're basically going to hang a bucket of water on this thing, and we'll just fill up the bucket slowly, so it's kind of a suspense thing. And then at some point the wing will break, it will fail, and we'll measure the strength. When did it break? How far did it deflect? And we'll also look at the weight of the thing. So it could be sort of an arena style situation where it could be the whole class watching, and the team is allowed close, and they can do the setup themselves.
Whenever planning a project, it is important to start by defining the student outcomes and working backwards, taking into account what the students already know, what they need to be taught, and what they will discover for themselves.
Can we actually list some of the key things that you want kids to understand?
I think the big one is equilibrium of forces. Another one is failure modes. So that's like how things can break, because there's a lot of ways things can break. Those are two ideas. So I mean, equilibrium of forces is your whole Newton laws. You know, I started thinking about it. My mind kind of just goes into all the things people ought to know. Of course, I'm looking at it from the perspective of somebody who's been doing it for 15 years. So I just take a step back, and Eva helps me, to say, well, we can't do the universe, so we just grab the fundamental things that the students can understand.
You're talking about something that presupposes calculus and a lot of years of physics, etc. Now we're talking about how do you take this project and break it down so freshmen in their first encounter with Newton's laws can do this project. And so Scott they will have learned Newton's laws before they do this, I'm presuming. But what are the science concepts that they won't have had?
Well, stress and strain is a little more complicated to me, but I think they can get it, because it's basically load and stiffness. As far as graphing is concerned, there's a linear portion, and then it starts to go nonlinear. So that might be a concept for math class. I'm a little hesitant, because I don't want to make it too complicated, because these concepts, I mean, I can go on forever, and it's way too advanced for basic class.
But I also see those upper level concepts, like for instance, we talk about this linear graph that turns into an arc. We'll focus on that. I'm hoping my students will be able to explain and get data, graph it, and do all these things with the linear, and we'll use that, I guess, the nonlinear functions to pique curiosity. Kids are going to like, oh man, I really want to learn about this now.
To introduce the project, teacher Scott McComb presents the increasingly sophisticated concepts the students will encounter as they design and build their wings.
Oh, a bending moment diagram. Oh, okay. I'm a reasonably smart person. I can figure that out. Sure, all right. A little first derivative, a little calculus. Okay, that's pretty good. All right. Oh, okay. Oh, my. Oh, my. Uh-oh. Oh, friends. Okay. Engineering is fun, and engineering is hard, or hard from the outside looking in. But once we get the hang of this, it's going to go like this.
So as I think about the essential questions for my class, based on the science standards, one of the essential questions is, how do we get better? How do we know more? And then is the price of science and technology worth it? That's for the application sort of piece of it. And then from the inquiry perspective, why do we do science? Does it matter? Why is it important to do science right? How do I know if I can trust the results of a particular scientific study?
This is perfect for that, because as far as why is it important, well, when you're flying on an airliner, it's pretty important to know what the strength of the wing is.
One of the strengths of project-based learning is that you're able to teach skills and content. So you want to deliberately think about not only the content that's related to your standards that you need to teach, but also the skills that you think students should learn during this project.
One of the things I did was to list the skills required. Things like research, predicting and justifying, measuring and estimating, design, testing, redesigning, retesting, graphing, making sure we have valid and reliable results, documenting the process, team responsibilities, communication, and effective write-ups. And so these, I think, are some of the sort of the process skills that they need. And now it's just a matter of making sure that we get the content and build it in there.
So Scott, what are the science content standards? How well does this project serve those?
With respect to the application standards, could not ask for something better. Could not. With respect to the balanced forces, it's brilliant. And I see the sort of the engineering concepts talking about design for easy assembly, material behavior, the stress and strain curves. This is, Michael, where I see actually help from you coming in, a math concept of scaling. How good is this? Here we have a small model. How closely does it relate to the big model? How closely would it relate to a really big model?
How representative? Okay.
Which I think, so that would also be a nice fit.
You know, the standards are a useful baseline, but they're not intended as the end line. So to start from the curriculum and start from the standards and say, this is where my students need to be at the end of this time. And then to say, how can I take this project and make it into a centerpiece that will stick? This is how new learning happens.
I mean, it seems obvious for me. You say, oh yeah, it's not moving, it's balanced force. You get kids, and this is a huge concept for students to understand, to say, what is a balanced force? What does that mean?
Right.
They don't understand, and not without lots of practice, and I'm super excited about this.
Good.